Rima is one of the world's leading manufacturers of hydraulic systems and components with innovative solutions for harbour cranes. With more than 40 years of experience in design and realization of storm brakes and hydraulic systems, Rima supplies equipment for thousands of cranes in hundreds of ports around the world. In the last 15 years, Rima has been the object of an organic growth, establishing a commercial network that covers 24 countries in Europe, Asia, Australia, and North and South America. The desire to be ever present as a prime mover within the market, together with the spirit of innovation, has inspired Rima over the past decades to continuously evolve its products. The same spirit has now triggered the conception and realization of the new TR rail clamp, whose concentration of technology makes it a unicum in the field of storm brakes. A panorama of the critical points of traditional pre-exiting rail clamps and improvements we can envisage. Contacts between rail clamps and rails, for example by roller guides or sliding guides. Traditional rail clamps have several kinds of guiding systems, like sliding rail guides, sidewise acting rollers, or in the case of clamps on wheels, guiding wheels which also bear the weight of the clamps. The contacts of these guides with the rail are a weak point, since the physiological wear of guides require continuous monitoring and frequent replacement of worn parts, which is costly and time-consuming. This problem is particularly evident for modern fast automatic stocking cranes subject to very heavy gantry duty. The elimination of any possible contact between rail clamps and the rail would be a remarkable improvement for performance, reducing the cost and time of maintenance. Compensation of wide horizontal and vertical floats. Traditional spring rail clamps cannot compensate wide vertical floats, particularly in the case of rail profiles with inclined flanks, unless an on-wheel solution is adopted, which is costly and calls for higher maintenance needs. The dimensions of last-generation cranes, and in particular the actual techniques for the realization of container stocking yards, which over time could induce significant deformation of crane runways, and therefore of rails, require rail clamps to be able to compensate big floats without jeopardizing their efficiency. A contactless solution with high float compensation capacity would solve this problem. Force applied to the rail and consequent wear of braking pads. Traditional spring rail clamps, once applied, irrespective of wind action or not, generate the maximum compression force on the rails through the braking pads, with consequent not negligible wear. This requires continuous monitoring and frequent replacement of the braking pads. A solution which applies force to the rail, proportional to wind action, would minimize the need of monitoring and the replacement of braking pads, leading to a considerable improvement. Peculiarity of new TR rail clamps with reference to the above 3 points. The rail clamp is completely guideless, eliminating any kind of contact with the rail. During closure, the rail clamp centers itself on the rail, compensating any horizontal shift, more or less 30 mm, and vertical shift, more or less 25 mm, suitable for practically all needs. For singular unique cases which require bigger floats, customized solutions can be studied. Once the clamp is closed, the braking pads safely clasp the rail sides without exerting high pressure on them, eliminating any source of wear. Only if the wind force applied on the crane, overriding the gantry brake capacity makes the crane move slightly, just a few centimeters, will the jaws start to squeeze the rail top with a force proportional to wind force. Therefore generating the required reaction braking force. Through this working principle, the wear of braking pads is very limited, therefore reducing the need for maintenance and increasing the safety of the cranes. Operation. The rail clamp can be operated by a traditional hydraulic unit and cylinder or by our electro-hydraulic thruster. Working pressure is very low, apart from rare cases of opening under residual braking forces, maximizing the life of all hydraulic parts. The adaptation of the thruster release system eliminates problems of leakage on connection piping and, most importantly, simplifies the electrical control of rail clamps by eliminating the need of a dedicated control panel. It is sufficient to feed the electric motor to open and keep the clamp opened, and then cut the feed to close the clamp. The possibility of having a stable adjustment of the delay of closure of the rail clamp, resistant to wear of the rail, is important for the safety of the crane. For traditional spring rail clamps, the closing time delay, calibrated through a simple throttling valve, is influenced by the variation of rail top width. To minimize the influence of the rail width, fabrication tolerances and wear on the closing time, we have created the following functions. As the motor switches off, the rail clamp starts a very small and slow movement, concentrating delay in this first closing phase. The second closing phase, which covers the biggest part of the closing movement, is very fast. This means the closing time is almost independent from the real width of rail top than from rail wear. TR version for rails installed in narrow trenches. For cranes running on rails installed in narrow trenches, in some cases STS cranes, we have conceived a dedicated version of the new TR rail clamp with particular features. This version can guarantee rated capacity even with huge tolerances on the rail head width, +1, -10 mm compared to the nominal width, and with wide vertical float. The above features allow the application of this clamp in sites where the status of rail maintenance is compromised, guaranteeing performance and therefore the safety of the cranes, even in case of severe degradation of runways. Last but not least, the guarantee of nominal performance of the rail clamps under wide wear of the rail, head width decrease of 10% compared to the nominal, is required by certain Japanese standards and has been already requested from us in a few cases by Japanese clients. Since the specific application inside narrow trenches limits the opening of the caliper opening, the adoption of rail guides is mandatory. However, the particular functioning of the guides we have conceived, which do not bear the weight of the clamp, and the modest duty of gantry travel for captioned trains, makes guide wear negligible.